Okay, this is the second method for basically the same question. So I'm gonna use the time for basically the particles to go in, in D, right? The particles to travel across T's, right? So I'm gonna use the Lorentz formula, which was T is equal, this is the second method, right? So T is equals to 2 pi, and you have the mass of the proton, which is 1.67 times 10 raised to power minus 27, right? And then you divide it by basically 1.6, right, times 1.6 is the Tesla, right? B, which is Tesla, magnetic flux density, and then you get the charge of the proton, which is also given at the back of your exam paper, right? So you get the time as for 4.1 times 10 raised to power minus 8 seconds, right? This is your time for the particles to travel from one day to another. Now you need to calculate the energy, because it says the time taken to accelerate a proton to this speed from rest. So basically it's traveling from 1.5 times 10 raised to power 7 to rest, right? So we're going to use the energy to find out how much energy was basically like obtained by the charge when he basically traveled, I don't know how many turns. We're gonna calculate that as well. I don't know how many turns, but like in a specific turns, how many energy did he got, right? So he got we got ek is equals to kinetic energy is equal to 1 by 2 mv square, and then you're gonna use 1 by 2 mass of the proton, which is 1.67 times 10 raised to power minus 27, right? And then you get the velocity as 1.5 times 10 raised to power 7, right? And then you square it, and then you get your energy as 1.8 times 10 raised to power minus 13 joules, right? Now you have been given accelerating potential difference. You have to convert it to basically joules or energy, and this energy is basically gonna give you for energy of one side, but how, because I'm going to use this formula to convert it into energy is equals to QV, right? Why I use QV? Because it's used for parallel plates, right? And we can say like it's similar, these are basically similar to parallel plates as well, it's going from one place to another, right? And parallel plates always goes from positive to negative, right? Basically positive to negative, basically, right? So we're gonna just get the energy of one side only from this formula, right? So once we calculate this, 1.6 times 10 raised to power minus 19, 113 times 10 raised to power 3, which is, this is the formula, this is the basically the value of the charge of the proton, and this is the V, accelerating potential difference of the the value that has been given in the question, right? So you get the answer as for this is 2.08 times 10 raised to power minus 15 joules, right? So this is the energy only for one side, because I told you that this formula is for only parallel plates. Parallel plates go from one, they have only one line, they go from only till one direction, from positive to negative. So this is only energy of one side only. One side basically means in this D, it's going from one side only till one side, right? Only one side. So this will help us to find how many, the energy, basically this is the total energy, because we have to divide it to find out the number of turns from it, because this is the energy for one turn only. One turn means the D, this is a D, right? And this is going from here to here, right? So this is basically one turn right here, one turn basically, because of the magnetic field it basically turns. So I just brought a straight direction right here, right? Just for the explanation purpose, right? So this is our total energy, and we divided by just for one side cycle, right? So you get this as 2.08 times 10 raised to power minus 15, right? And then you get the number of turns from it, which is basically 90.4. This is for only one side, but as we know, if it wants to go 360, it basically goes till 2 turns, right? 2 orbits. To complete orbit, we have to divide by 2, for a complete orbit, right? It goes one time here and one time here, so we're gonna basically divide it by 2, right? So basically we're gonna get this answer as 45.2. we're gonna get for the orbit, you know, for the whole orbit that it gets, you know, it's having also 0.2 means it did not complete the whole, it was somewhere like here, you know, 45 orbits it completed, you know, 45 circles it completed. So now to calculate the total time, right, total time, right, basically we're gonna use the we're gonna use 4.1 times 10 raised to power minus 8. This was the time, like basically for you know, as I told you before, is the time basically, or this is the Lorentz expression we gain from Lorentz expression. The time is from basically going from one direction to another, right, basically going around the day, right? So this is 4.1 times 10 raised to power minus 8, right? And we need to know how many orbits it completed. So it completed 45.2 orbits, right? So this is only for one orbit. So for 45.2 it will be basically 1.85 times 10 raised to power minus 6 second, right? So this is your answer basically, right?